This is Team WhatTheHack2, and for this project, we will build a sound alert system app. To introduce the members of the team, we have Amber, who's a front-end engineer focusing on functionality and user experience. Lena, who's a back-end engineer focusing on the structure of the app. June, who's a back-end engineer focusing on the infrastructure. Peter, who's a research analyst focusing on the performance usability of the app. Waipan, who's a research analyst focusing on the functionality of the app. To give a bit of motivation for why we're building this app, we'll give a bit of background. So in a world that's increasingly being interconnected, where smartphones, smartwatches, and headphones are integral parts of our lives, it is very important to ensure that people are always aware of their surroundings. And distractions caused by smart devices can lead us to be oblivious to emergency situations.
Diving deeper into the problem we face today, critical sounds that could save lives will often go unnoticed when an individual is absorbed in the digital world with earphones plugged in. This can be a fire alarm or a gunshot nearby, which can be easily drowned out by the noise caused in our digital lives. And the solution we want to create is to solve this pressing issue, we have developed the Sound Alert System app. This app aims to serve as a guardian angel to users by quickly alerting them of potential nearby dangers through notifications describing the severity of the distressing sound.
All right, on this slide, we'll outline the timeline and key activities for this project. On week 1, it marks the project's initiation. We have already passed that phase, but it is to investigate and choose a candidate pool and begin coding for the prototype. During weeks 2 and 3, the progress continues. We'll continue coding the prototype, prepare task analysis, formulate interview questions, and commence on the data preparations. In weeks 4 to 6, a user study takes the center stage. The user study begins with interview session 1. We continue data preparation from the interviews. We begin user study 2, which is the interview session 2, and it will conduct data analysis. Moving on to week 7, we'll initiate the user studies 3 and prepare demo materials. And finally, from week 5 through week 10, the project nears our completion. This includes shooting the video of our app use case, editing video, finalize our reports, and our data analysis. This well-structured project timeline will guide our project's progression, ensuring that each phase is diligently executed.
Well, on this slide here are some examples of a procedural code that can be used to improve the app. While our app prototype is currently under development, we are continuously refining the code for future iterations. So here is a snippet of our procedural code that we are implementing in our app. This will be the sound detection layer in which the noise gets read into our database. The app will read it and set a threshold based on the noise decibel, frequency, or wavelength. Once the sound gets over a certain threshold, it will trigger an alert, and the alert will classify it as either dangerous or potentially dangerous. And here is our demo. So now let's dive into the app. So here is the main interface. As you can see, it's designed to be user-friendly. So right now we have 2 major functions, the noise detection and the timing ML models. So right now the tiny ML function is still under development. So today I'm going to focus on the noise detection, which is consistently monitoring ambient sound levels, as you can see here. So for normal conversation, it's usually about 50 to 60 decibel. Prolonged exposure to sounds above 85 decibel can cause hearing damage. And when the app detects sound levels between 90 and 100 decibel, it sends out a potentially dangerous sound alert. So for example, like this. And this is to inform the users to be cautious. And when the sound level goes above 100 decibel, the app sends a more urgent, dangerous sound alert, advising users to avoid the area or use protective equipment. Let me try to create a very loud noise. So as you just heard, so this is the dangerous sound alert. We understand that the importance of immediate attention to these alerts. So that's why we introduced distinct notification sounds for each alert type, ensuring the user can differentiate between them even without looking at the device. So on the technical side, our app utilizes the device's microphone to continuously record ambient sound, processing and analyzing the data in real time to provide instant feedback. So right now we are in the middle of the development, and of course there are flaws. So for example, the sound has been roughly but not very precisely calibrated. So the decibel is not accurate as of now. And the alert is not given the dismiss button. So we'll add that later. And we'll later give users the setting option to customize the threshold also. And lastly, we will also deploy the tiny machine learning models in the app to predict the sound types, for example, ambulance or fire truck sirens. That's all for the demo. Thank you.
First and foremost, the user can grant the app permission to access their device microphone. This is crucial as it enables the app to continuously record audio in the background. On the graph shown here, when emergency sound is emitted on step 1, then the sound will be detected by the smartphone's microphone on step 2. The recorded audio is then securely transmitted to the app's backend server for analysis. On step 3, in the backend, the audio data is stored and subjected to thorough analysis. Complex methods such as machine learning and signal processing are used to identify abnormal or high-frequency sounds. What's useful is that the user has the ability to customize the system by setting sensitivity thresholds to align with the user's own perception of what is potentially dangerous. The sound data will then be stored in the database, and on step 4, the system classifies the detected sounds into 3 categories: dangerous, potentially dangerous, and normal. These classifications are made based on the predefined thresholds and the outcomes of the analysis. If a sound surpasses the set threshold and falls into the dangerous or potentially dangerous category, the app triggers an alert that is sent directly to the user's smartphone, shown in the last step here. Upon receiving the alert, it provides the user with a clear understanding of the type and level of danger detected. The user would then be given the option to dismiss the alert or follow any recommended actions. Additionally, the system logs all the alerts and the corresponding audio data, which the developer can review for further analysis and app improvements. The users can rest assured regarding any privacy and security, as the app ensures data encryption during the transmission and acquires the user's consent for audio recording, guaranteeing the compliance with data protection and regulations. The system also puts the user in control, allowing the user to enable or disable this feature, fine-tune the sensitivity thresholds. It continuously to learn and adapt based on the user feedbacks, which over time will enhance its accuracy and sound detection.
There are several problems that we encounter during the process. So the first one is that we are calibrating decibel restrictions in the app prototype. Secondly, we encounter some framework development errors, which we saw. And thirdly, we are currently establishing optimal threshold settings. Finally, we are currently enabling background voice recording while users use their phone. So here are our next steps. We will iterate and complete our prototype, and this involves 2 steps. The first one, we enhance our code for more accurate results by testing various models. And the second thing is we need to store noise files into our database. We will also conduct user studies and gather feedback once it is ready, and we'll perform data analysis. And lastly, we will finalize our app based on our users' feedbacks.